In Module 4, we devote our attention to volcano deformation models and their role for understanding magma movements in volcano roots. Measurements of earthquakes, ground deformation, and volcanic gas that have been covered in earlier modules need to be interpreted with models. With a model, we can, for example, predict the response at the Earth's surface to magma accumulation inside the Earth. By comparing model predictions to observations, the aim is to judge if a model is realistic and if bounds on model parameters can be derived. This can, for example, be the depth of magma accumulation and volume of magma that is moving. Models for ground deformation fields on volcanoes have been widely used to understand magma movements. And in this module, we will have a look at them. There are a number of issues one has to be aware of relating to the assumption of models. Commonly, the models assume the magma is a fluid of uniform properties, and the host rock of magma is solid of uniform properties, most often assumed to behave as an elastic material. We start with the simplest model, assuming a spherical source of increased pressure inside volcanoes. Then the predicted displacements are symmetrical with respect to the source center. But many intrusions are sheet-like, dikes, or sills, and for these the deformation fields are different. A dike will push the surrounding crust to both sides, in a different manner than a spherical source. Therefore, the deformation fields can also give information about the geometry of magma bodies involved. We end this module with an introduction to methods used to fit geodated data to ground deformation models, and how uncertainties on model parameters can be inferred. So welcome to Module 4.